Did you know that the planet Mercury, despite being closest to the Sun, experiences the largest temperature fluctuations in the solar system? Yes, it's true. On this miniature world, temperatures can plunge to a chilling negative 173 degrees Celsius in the pitch black of night, only to soar to a scorching 427 degrees Celsius in the full blaze of day. Astonishing, isn't it? You might be wondering why this is the case, and we will delve into that, along with other fascinating facts about Mercury. Mercury, our solar system's smallest planet, is only slightly larger than Earth's moon. Just to give you a sense of scale, if our solar system were a family, Mercury would be the little sibling, always trying to keep up with its larger brothers and sisters. It's dwarfed by giants like Jupiter and Saturn, and even our own Earth is significantly larger. Despite being the smallest, Mercury is not to be overlooked. Its diminutive size is a part of its charm, making it a unique and intriguing part of our cosmic family. It's like a compact car that's been packed with features. If you were to take a stroll around Mercury, you'd complete your journey a lot quicker than you would on any other planet. Its equatorial circumference is roughly a third of Earth's, meaning it would take you a lot less time to circle the globe. And yet, despite its small size, Mercury holds some big secrets. Mercury has survived a giant asteroid impact that was so powerful, it left a massive multi-ring basin named the Caloris Basin. This colossal event, occurring billions of years ago, was so intense that it permanently scarred the planet's surface, leaving behind a basin stretching across 1,000 miles. The impact was so powerful that it created a phenomenon known as weird terrain on the opposite side of the planet. This terrain is a jumbled, haphazard collection of hills and valleys, as though the planet itself crumpled under the force. The Caloris Basin and its effects have greatly influenced our understanding of Mercury. It's a testament to the violent history of our solar system and provides valuable insight into how terrestrial planets evolve over time. These scars on Mercury's surface have become a roadmap to its past, and by studying them, we are able to glimpse into the history of our solar system. Mercury is a survivor holding on to its secrets despite the ravages of space. Mercury's orbit around the Sun is not like any other planet's. It's eccentric, meaning it's not a perfect circle, but an elongated path that brings Mercury closer to and further from the Sun at different points on its journey. This eccentricity is part of what makes Mercury's orbit so unique. But that's not all. Mercury has a peculiar spin-orbit resonance, rotating 3 times on its axis for every 2 orbits it makes around the Sun. This is a result of the Sun's gravitational influence tugging on Mercury's elliptical orbit and slowing down its rotation. So, why is this significant? Well, this unique spin-orbit resonance means that a day on Mercury, the time it takes for the Sun to return to the same spot in the sky, lasts 2 Mercurian years. Mercury's bizarre orbit is just another one of its many mysteries. It adds to the allure of this tiny, ironclad planet, making it a fascinating subject of study in our cosmic neighborhood. Despite being the closest planet to the Sun, Mercury has ice on its surface. Yes, you heard that right, ice. The scorching hot Mercury, with daytime temperatures soaring up to 800 degrees Fahrenheit, harbors ice at its poles. This ice was discovered in the 1990s by Earth-based radar observations. It exists because Mercury's rotational axis is almost perpendicular to its orbital plane, allowing some areas near the poles to remain in perpetual shadow. These chilly, sun-starved regions act as cold traps, freezing any water molecules that wander in. This water ice is thought to have been delivered by comets, or produced by chemical reactions between the solar wind and Mercury's rocky surface. You see, the ice tells us that Mercury, despite its extreme environment, has a dynamic and complex history. Mercury's icy poles are a surprising contrast to its scorching days. Mercury's iron core is enormous, making up about 85% of the planet's radius. Now that's a lot of iron. This core is not just large in size, it's also rich in composition, primarily made up of molten iron. The discovery of this gigantic core was no easy task. It took years of observation and data collection from multiple space missions. Scientists utilized techniques like radar observations and gravity measurements to piece together the puzzle of Mercury's interior. But why is this core so important, you might ask? Well, it plays a crucial role in Mercury's magnetic field, which is about 1% the strength of Earth's. This magnetic field suggests that Mercury's core is still partially molten, a surprising fact given the planet's small size and old age. The large iron core also hints at the violent processes that could have shaped Mercury during its formation and early history. Mercury's iron core is a testament to the planet's fiery past. Every inch of Mercury's surface has been mapped, revealing a world of craters, smooth plains, and a thin, almost non-existent atmosphere. Imagine a world where the landscape is pockmarked with craters, echoing the violent history of our solar system. That's Mercury for you. With its surface meticulously mapped, we've been able to uncover details that were once only figments of scientific speculation. The planet's surface tells tales of meteor impacts and volcanic activity, shaping a landscape that's both rugged and eerily beautiful. This mapping has also revealed something unexpected: smooth plains. These are thought to be the result of ancient volcanic activity, a testament to the planet's fiery past. But amidst these chaotic landscapes, there's also a sense of stillness, a testament to Mercury's present tranquility. But let's not forget about the atmosphere, or rather, the lack thereof. Mercury's atmosphere is so thin it's almost non-existent. It's composed largely of oxygen, sodium, hydrogen, helium, and potassium, but these elements are so sparse that they can barely be called an atmosphere. This thin veil does little to protect the planet from the harsh realities of space, contributing to Mercury's extreme temperature fluctuations. So, what does this all mean? Well, the detailed mapping and study of Mercury's surface and atmosphere have given us valuable insights into its past, its present, and possibly its future. Mercury may be small and close to the sun, but it's a fascinating world full of surprises and mysteries waiting to be uncovered.